All right, for number 2, we're trying to find the local mins, local maxes of this function on this interval. So first, we're going to find our critical values from finding the derivative when it's 0 or does not exist. Derivative tangent is secant squared. Minus 2 times derivative secant is secant times tangent. So we can factor our derivative out. Take a secant of x out of each of these. And we have secant of x minus 2 tangent of x. So to find our critical values, we need to figure out when is this 0 and when does it not exist. So let's first, when is the derivative 0, and then we'll take a look at when is the derivative does not exist. So it's equal to 0 when secant of x equals 0, or when secant of x minus 2 tangent of x equals 0. If secant is 0, cosine of x has to be the reciprocal of that, which is 1 over 0, and that's not possible. Over here, not too comfortable using secant and tangent. I'm more comfortable with sine and cosine, so I'm going to rewrite this as 1 over cosine of x minus 2 times sine of x over cosine of x equals 0. From here, since they have the same denominator, we can go ahead and make this one expression, 1 minus 2 sine of x all over cosine of x equals 0. Now in this case, we can look at two things. 1 minus sine of 2x, if we set that numerator equal to 0, that's still going to give us when the derivative is 0. So 1 minus 2 sine of x equals 0. So sine of x, if we subtract 1 and divide by negative 2, we get 1/2. We want to find out where's the sine equal to 1/2. Well, that would happen at pi over 6 and 5 pi over 6, but we're only going from negative pi over 4 to pi over 4, so our only solution in that interval is pi over 6 from that. Well, if we take this denominator, denominator and set it equal to 0, that's actually going to make the derivative not exist. If the cosine of x equals 0, then our derivative does not exist. So cosine is equal to 0 at pi over 2 and 3 pi over 2, but neither of those fall within our interval here. So pi over 2, 3 pi over 2, not going to work out for us here. The other thing we have to take into account when the derivative does not exist is secant, remember, is 1 over cosine. So if cosine is equal to 0, we've already done that, but if we hadn't done that right here, if cosine is equal to 0, that makes this undefined. But we've already done that here, so we're not going to do it again. And then inside here, secant of x minus 2 tangent of x, kind of taking care of that within here. Again, cosine of x would have to be 0, because this is 1 over cosine of x minus 2 sine of x over cosine of x. So if cosine of x is 0, it's undefined, but that's not in our interval. We've already solved that. So let's move on here. We've got one critical value. Let's put that on our number line and figure out if it's a minimum or a maximum. So it's 0, the derivative is 0 at pi over 6. We can go ahead and try derivative of 0. It's an easy one. If we take secant of 0, that's the reciprocal of cosine. So cosine is 1. This is going to be positive. Here, so we're going to have secant of 0, that's 1, minus 2 times tangent of 0. Well, tangent of 0 is sine over cosine. That's going to end up being 0. So this is positive. So we're going to have positive derivatives over here. If we try one to the right of pi over 6, let's try pi over 4, because that's in that interval. Pi over 4. If if we put pi over 4 in here, secant is 1 over cosine. Well, since we're in the first quadrant, secant of pi over 4, that's going to be positive. Cosine's positive, reciprocal of that is positive. And tangent of pi over 4 we know is 1. So this is going to be like minus 2 times 1, so minus 2. Secant of pi over 4 is the reciprocal of cosine. So cosine is root 2 over 2. Reciprocal of that would be 2 over root 2, or simplifies to square root of 2. We end up with square root of 2 minus 2. So this is going to end up being a negative value. All right. So in this case, we have a local maximum at x equals pi over 6. Right, because it changes from increasing to decreasing at that x value, at that critical value.